Welcome everyone. It is February the 6th, 2014. Right now, well, we got a relatively balmy 30 degrees outside. Yesterday we had a foot of snow, and the weather is still very, very cold. And so, as I've said in the past, we won't be imaging the moon for a while. Waiting for the weather to cooperate a little more with us, so it's not so brutal out there. So I'm just pulling up some of my past work and pass on some of the things I did to you in the some of the things I did in the past in my observatory. And what I have on the screen now is an old photograph of my original main instrument for the observatory way back in the 1990s. It is a 16-inch Meade Cassegrain, and it's was remounted. I took this tube assembly and made a lighter weight aluminum tube for it, and the axes here, the polar axis and the declination axis, they're run by motor, and you sit there and you hand control, and you can guide using, let me see if I can get this to set a little better to get a little better image here. You use this secondary scope here as a guide scope, and you follow your guide star and get nice images. And of course, that was the day before computers. And that was in the day when you found things manually. You used this circle here was the right ascension circle with a pointer on it, and the declination circle over here. And you would use right ascension, declination, and sidereal time. And that's how we would locate things in the night sky. Far different from today when we use our nice go-to equipment where everything is done for you. I've got to plug my computer in. It looks like my power started to drain down a little bit. I had a little power issue when I was trying to do something a while back. Let's hope that does not happen again here. But anyway, what I'm getting at is this is what I used to use to find things before I got my computerized mount. And what I used to study, and I still like to, and by the way, that photograph in the background is Comet Bennett from way back in 1970. If I have a chance, I'll go into that a little bit. But the stars I studied were... Let's flip that around, it'll probably be a little better. These were the types of stars that I studied. They are called cataclysmic variable stars. You have a very massive main star here, a much larger but less dense red giant star here, and this star is so massive that it actually causes a tidal pull. It pulls material off of this smaller star, not smaller star, but less massive star, but a much larger star, and pulls it into this bridge here. Now, after a certain amount of time, so much material builds up to this point right here, it causes that star to completely just go bang. And what happens, and let me see if I can find that, is this. Here's what happens to, let me see, I might have to turn that around. Here is, this is the star DQ Hercules, or Hercules, Nova Hercules in 1934. And over here, we have it at its normal state. let me see if I can get my big hand out of the way. See it over here at its normal state? It's just that small star, normal looking star. And one night in 1934, so much material had crossed that bridge and built up on the edge of the massive small star that it just caused a huge eruption, and we got this over here. And for quite some nights, that was one of the brightest stars in the nighttime sky. Fantastic objects to study, and that's what I became hooked on, and that's what I worked on for a number of years before I retired and started doing my moon videos. What makes this work hard, though, is that you have to go and find these things manually with that mount that I was showing you. And you get to, let me see if I can get this. This is going to be a little tougher to, there we go. This is back in the old day when you did things by hand. This chart represents an area of sky that if you were to hold your hand out and look at the area of your little fingernail, that's about how big of an area this is in the night sky. This chart area right here would be about the size that your little fingernail covers up. So it's a very small area of sky. And what you have to do is, using those setting circles, is set your telescope on that area and then look around the charts and different things and identify like this double star here, that bright star here, and maybe the couple of the fainter stars off here. In other words, you look for guideposts in the chart and verify that you're in the right area. Once you do that, then you can make your observation. And I'm going to blow this up so you can see that a little better. And then let's see if I can explain how we do that. And I'm checking the temperature of my computer, because my computer problems I've had, it's a thermal issue, and I just don't want it to get hot on me again and quit. I had it quit on me as I was trying to get the first one done. But that star with a cross on it is our variable star. And normally it's at magnitude 12.3, which is about as bright as that star right there. See, it says that 1, 2, 3, that represents 12.3. What they do is they eliminate the decimal point. All these magnitudes are to a tenth, and they eliminate the decimal point so it's not confused for a star. So then what you do is you look at our field and you look at our variable, and then you find some stars that are in here that are very close to brightness to your variable. Now let's say in this night this star, which is SS Cygni, is very, very close to that star right there, which is marked 120 or 12.0, but maybe a little bit dimmer. Now this star up here is marked 128 or 12.8. So that's even fainter. The higher the number, the fainter the stars, which you've got to remember. So then you would say, well, okay, we're closer to this star at 12.0, but we're not as bright as 12.0, so we're getting somewhere down not close to 12.8. So you have to determine in your mind, is it closer to the 12.0 or closer to the 12.8? Now, most times you would have found that that star was closer to the 12.0, and you would give it something like a 12.3 or a 12.4, and that's where it would be at its minimum phase. And that's basically how variable star work was done back in the old days, with just a simple telescope and a mount where you had to go dig things out yourself. I want to show you in the background here while we're on this. See if I can get it to come in a little better. There we go. That's not too bad. That's Comet Bennett. That photograph is 44 years old come this April. There's a bit of a story about this. I'm checking my computer again to make sure it's not getting too hot on me. It was actually the middle of a week. It was, of course, a work day. I had to get up about 2:30 in the morning. I went down to the observatory, set up, and my camera got attached to the end of the telescope, and you just let the telescope run as long as it was set up. And after about 8 minutes of photography, you would close the shutter and take your film in and develop it. A trick we used to use was you would put a cap over the shutter. So when you opened it up and jiggling things around the telescope, things wouldn't shake and you wouldn't get an image with all kinds of shakiness on the stars. You would open the shutter, hold the hat in front of the lens away from the telescope or away from the camera for a few seconds, let things settle down, and then pull the hat away. And that started a nice smooth exposure. You ended it the same way by putting the hat over the lens, closing the shutter, and then you could do anything you want. You wouldn't disturb it. Well, I did that on this night, went in the house, and this camera had a setting on it for focus. One side was set to the limit. It was for very close-up head and shoulder shots for portraits. And if you rolled the shutter setting all the other way around to the other marker, you were set for infinity. Well, through my stupidity in rushing in the first night, I forgot to really check the setting for focus. And I ran into the house, developed, before I went to work, hopefully I'd have a nice day, thinking I had some nice prints to make when I got home. I had accidentally left the focus setting at the portrait setting of the 3.5 foot to 4 foot setting, and my exposures were completely out of focus. So I had to set my alarm for 2:30 the next morning, which luckily turned out to be just as nice a night. Went out, went through the whole ball of wax, this time double checking the setting of the focus. And it was set on infinity, and I ended up getting this nice photograph of Comet Bennett. That and $1.50 will get me a cup of coffee, but it was one of my first real successes in photography, and I was really happy with that. Some of the other things I did, I can show you one more quick thing. This is, let me see. I have to put that in this way, and let me see if I can drop it down a bit. This is the Galaxy M81. 100,000 light years across, just like ours, with about 100 billion stars. This photograph was taken on March 9th, 1980. This one was taken April 18th, 1993, 13 years later. Notice there's a white arrow coming in and pointing to a star here, which makes a triangle. Well, notice over here that triangle star is missing on this side. There's a very faint star there, but that's not the brighter star that's here. That is a supernova that went off in that galaxy. And it's amazing that for about a month, that star is putting out more light than all the other stars, all of the 100 billion stars in that galaxy together is being put out by that one star. So, again, that was done back in the days of film. Let me show you just very quickly some results that I got from my working on some of these variable stars. And then I want to show you something that I think is pretty neat. And again, that and $1.50 gets me a cup of coffee. But this was the results that I would get from. Let me see. I've got to fool around with this and get. Let's get this set up where we can see what's going on a little better. It's a little tough getting this background set. There you go. This star is actually, the number it's got to it is a V1315 Aquila. And you can see what's going on here. You've got the star, doing its thing here. This is done all now by computer. I'm back in the modern day with the computer. And then it would go through an eclipse, and very quickly the star brightness would drop down. This drop in brightness was about 3 magnitudes, which is a big drop, and back again. And this whole period here takes about 45 minutes. roughly half to go down and half to go back, and then it goes back to its normal curve. That's what I was studying in these stars, these cataclysmic variable stars. Now, you remember I showed you that picture of what a cataclysmic star is. There's two stars there, don't forget. They orbit each other, or I should say they orbit a common center of gravity. But hang on, I'll check this phone that's ringing and make sure it's not an important call. And it is not, so it's going to just ring. Now, what happens is those stars go into eclipse, and that's what's happening here. You're watching the star do its normal thing through here and out here and here. And here's where one star is passing in front of the other and cutting the brightness way off. Now, I have another set here which shows one way we used to do calibration when we were working on those stars. This is a different type of star doing a different thing. The star that I'm studying is down here, and you can see these minor bumps. There's something going on there that was under study by the group we were working with, and we were studying that. Now, notice up here you have this line that looks relatively straight. That's just a calibration that we used to do. We would take two stars in the field, and one of them would get used as a comparison star to actually make this graph down here, and then we would compare these two stars together, and to make sure everything was working good, we would try to pick two stars that did not vary in brightness. So if they don't vary in brightness and you compare one to the other, this line should relatively be a straight line. Well, in this case, as you can see, it is. It's relatively straight. We have a couple outliers here and there, where that could be caused by atmospherics or a number of things. But for the most part, it's pretty much just a straight line. So the system was working good, and you can see that nothing was really going on here. But down here, you can obviously see that there's big changes going on. So there was definitely something going on with those stars there. So that was the fun part of that. Now, I might have left what I really want in the other room. So enjoy the picture of Comet Bennett for 1 minute, and I'll be right back. Okay. Alright, sorry about that, guys. I wasn't quite prepared for this. Now, this is something that I really find amazing, and I hope I can get it to show up on the screen for you. This is, it's a little tough. Let me see if we can get a little higher magnification. Keep on playing with his brightness. It's going to be a little bit tough, but I might be able to pull this off. And as I say, this and a cup of coffee, or $1.50 to get me a cup of coffee, is about all it is. But it is one of the most thrilling things that I think that I actually pulled off while I was doing astronomy. And this goes back to the days when I did not have my go-to telescope. This is when I had the old honker 16-inch, and I used to have to push it around by hand and find things in the sky by hand. Back in 2003, what was then called the 10th planet was discovered by a Mike Brown. He discovered an object outside the orbit of Pluto. Now, Pluto was always thought to be an object that was odd. Its orbit did not match the rest of the orbits of the planets. It was inclined to the plane of the solar system that we are in with the rest of the planets by 17 degrees, which is a lot. Its orbit is not centered on the sun very well. It actually comes inside the orbit of Uranus at times, as it was in the 1980s. In the 1980s, the planet, I'm sorry, not the planet Uranus, but the planet Neptune. In the 1980s, the planet Neptune was the most distant planet. But it got named as a full-fledged planet. Now, we grow up, we go through school, and we know we learn the 9 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Well, see that little tick mark? And in the photograph, let me see if I can get my hand here so it's not in the way. There's a little tick mark there, and next to the tick mark there's a very faint marking. Right there's another one. Just a very, very tiny little dot. That dot killed Pluto. It turns out that Pluto is a number of a class of objects we call Kuiper Belt objects. They're dwarf planets. They are inclined by all varying sizes to the main body of the solar system, and their diameters are generally very small. This object turned out to be bigger than the planet Pluto. Turned out that it can go as far as, let's see, off the top of my head, I left the paper out in the other room and I do not want to leave the mic to go get it. I believe it's on the order of at least 5 times farther from the sun. Now, finding this object was a real chore. Most of the guys with the big modern day equipment set the coordinates in, and the telescope would do its thing. They would identify the stars, and bingo, there is what was then known as UB313, the number given it to before it got its name. Its final name came out to be Iris for the planet. Now, this first photograph over here, where the pen is pointing, notice first of all, let's get its location. Notice here you've got this little triangle. So over here, here's our little triangle, just so we know where we are. Now, come over here. Notice there's this faint triangle right here. On this photograph, here it is again. Here's our faint triangle over here. Now, notice that off of that faint triangle in the first photograph, we have this faint object up here. Now come down to this photograph. There is our faint triangle, and notice there's nothing up here where this guy was over here. We came down to the bottom of this triangle, and there is our tiny little dot. That's Iris. That object is bigger than Pluto. It's 5 times farther away out of the solar system from Pluto. And that is how far it's moved from November 26, 2005 till December 1st, 2005. Now, remember the old fingernail experiment I said, you hold your hand out? Well, this area, hold your hand out, look at your fingernail, your little fingernail, divide it in half, then divide it again, so you've got 4 quarters. Those 4 quarters, take one of those little quarters, and that's approximately the size of this area, the photograph we're looking at. And well, that was really stupid. I really covered that up. But here, this area right here, that is really the size of a quarter to the size of your fingernail, and the size on the sky. It's a very tiny field. So just the fact that I was able to manually put the coordinates into that telescope, use charts with my finder scope, comparing stars, nearby stars, worked my way to this field until I got to this object. It was a thrill. I had gone to the very edge of the known solar system. And it was just a thrill as an amateur. The equipment I was using was made by Meade Instruments. The telescope was Meade. The camera was Meade. The mount was not. The mount was a Starliner. But I sent the data into Meade telescopes, and for about 6 months, this double photograph was well shown on Meade's home front page for their advertising. I actually got this published, and they used it as a selling or drawing point in their main catalog online. As I say, that and $1.50 will get me a cup of coffee, but I don't care. I was floating on air. I had gone to the edge of the solar system with a small, relatively small, 16-inch telescope, and I had a ball doing it. So that's about it for tonight, guys. As I say, we're into February. The weather's still really, really crummy. There was a possibility of another big storm this weekend. It looks like we're going to dodge that. And I'm kind of a kid at heart. I like the big snowstorms, but it looks like we're only going to get a small snowfall out of this one. But the weather's staying very, very cold, so I wouldn't be a bit surprised if we don't go to March and almost maybe the first part of April before we get out and start doing lunar videos again. But I do have lots of the objects and things to show you, like I had here. I've got stuff laying all over the bed that I was ready to show you, but time just goes by too quick. I don't get a chance to really pull it all out and show it to you. So I thought I would just give you those few things to chew on and take a look at, and show you some of the things that I used to do and really enjoy doing. And this last one, I know it does not look like much, and it's probably very, very hard to see on your screen. I don't know if I can do any more to darken that up or not. Darken it up a little bit. And there again, there's our, my hand keeps on getting in the way. Right there, just barely see it, is location number 1 off that bright star. Now off that bright star, now you've got to come way down here. And there it is. That's how far it's moved in, what, let's see, about 5 days. Eris, the very, very edge of the solar system, and the guy that knocked Pluto from the ranks of the major planets of the solar system. So the kids in school today now are learning that we have 8 major planets, and a bunch of these objects called Kuiper Belt objects or dwarf planets. So for that, now guys, is going to be it. As I say, I'll probably end up putting something together again down the road before we actually get back into doing some more imaging. Looking forward to doing that, but this winter is just hanging on. It's really tough, so it may be a little bit longer yet before we get back to some live lunar imaging. So in the meantime, I hope you got a little enjoyment, or enjoyed a little bit of looking back into time and some of the things that I did accomplish using some other equipment. Until the next time, guys, though, good health, clear skies, and look forward to seeing you with some live video pretty soon as Old Man Winter decides it wants to let go of us. Have fun, guys, and stay healthy. Talk to you later.